Which innovative ideas arose to take on this new challenge? First, it was necessary to increase the energy of the colliding particles to study the properties of the newly discovered quarks. To that end, accelerators with a new type of magnetic system were invented. Those were accelerators with the so-called magnetic systems with separate functions, where the focusing of the beam was performed by magnets of one type, while the beam bending was carried out by another type of magnets. With such a structure of the magnetic system, it was possible to reduce the electric power needed to accelerate a charged particle beam several-fold. It became possible to considerably increase the accelerator circumference. Second, to raise the energy of the interacting particles in the center of mass system, the construction of accelerators with colliding beams began, the so-called colliders. To further increase the energy, with the same size of the accelerator, an emergence of superconducting magnetic systems followed. What projects were implemented based on this idea? To start with, the invention of the magnetic systems with separate functions led to the creation of two new enormous accelerators. The first one is the main ring of the Fermi National Accelerator Laboratory in the US. The circumference of the ring amounted to 6.3 kilometers. The accelerators started operating in 1974. The maximum energy of the proton beam reached 500 giga-electron volts. Around the same time, the European Organization for Nuclear Research, also known as CERN, began the construction of their accelerator. It was the superproton synchrotron, with a circumference of 7 kilometers. The maximum energy reached at this accelerator was 400 giga-electron volts. The first linear collider was built based on the linear accelerator at Stanford. The Stanford Linear Accelerator was equipped with an auxiliary channel of positron production and two arcs at the exit of the accelerator. The Stanford Linear Collider allowed for the collision of electrons and positron, with each beam reaching an energy level of 50 giga-electron volts.